Okay, so what is fluid? We have studied matter. Matter are three types. Yes or no? Solid, liquid, and gas. Yes or no? We have studied in 9th class, 10th class that matter are of three types: solid state, liquid state, and gaseous state. But there comes another phase of matter that is called fluid. Okay? Fluid comes from a word called flow. Something which flows are called fluids. So what flows? Gas also flows, liquid also flows. So this liquid and gas are called fluids. Normally it will be semi-solids, something which come here, that called semi-solids, like honey, mercury, plasma, or any iron in the molten states. They are called semi-solids. So semi-solids has the property of solid and liquid. They are neither very thin as of like water, and they are not so rigid and sturdy like solid. They are middle. So they are called four state. They are called plasma state or fluid state. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Similarly, liquids do not have their own state, like we know. Liquids will take, if you put it in a container, in a glass, it will take the shape of the glass. If you put it in a bottle and a jug, it will take. So they don't have any fixed shape. We all studied this in our 9th class, that they don't have any fixed shape because the intermolecular force of attraction is very, very less. These are all basics what we studied. Yeah. So solid being the rigid and others are not so rigid. So we will study about various liquids. What are the various, what is viscosity? We will study about this word called viscosity. Why honey? If you drop honey and water, which falls faster? Honey or water?
Water.
Honey falls faster. Huh? If I drop honey and if I drop water, which will fall faster? Honey or water?
Water, sir.
Why? Why? Because water has less viscosity. There is a word called viscosity. We will study about that. Viscosity. Every liquid has a different viscosity. It's a property of a liquid. A honey will have highest viscosity. No, you have something called, have you eaten jelly belly? Have you eaten that? Like a gel kind of thing.
Yes.
That is the highest viscosity. Okay, it's very sweet it is to be. Custard. It is not solid, it's not liquid, it's something middle. But in the middle plasma state also, because of viscosity, the property will change. Okay, so we are going to study about that. Surface tension, we are going to study all this. Okay, just to start with, a fluid either has no rigidity or it's very low, right? Plasma. They are not so rigid like solid. They are not so fluid like water. They are somewhere in the middle. It is not fully like a solid. It is not fully like a liquid. It is something like a middle. So it is not so rigid like solid, not so fluid like water. They are called plasma state or fluid. So if somebody asks you what is a fluid, say anything which flows is called fluid. A substance which flows is called fluid. Is it clear?
Yes,
Is
sir.
it clear? So when they're not rigid, what we can do? We can deform. Means what is deform? Deform is a negative of form. I want to give somebody a form. I want to give. There is a chunk of mud. I am giving as a nice shape of an idol. So you are giving a form. What is deform? If you want to break that. So what does liquid do? Liquid shape continuously deforms. If you put it in a container, it takes the shape of a container. If you put it in a like a ball, it takes. That means the form is not constant. Continuously the form changes. Under what? Under pressure and force, external force. If you take a jelly, if you have a jelly which comes in a, I think a wrapper, it comes like this. Have you eaten? It comes like this. Yes or no? Or maybe some shape like this. What will happen?
Yes.
If I remove the wrapper, the plastic covering, and what I will do, I will press it in my hand. Will it not become like a completely what do you call that, completely get pressed down. Why? Because of the pressure of the external force, I am changing the shape of the liquid. Is it clear? Is it clear?
Yes, sir.
So if somebody asks you what is a fluid, again you say fluid is something which flows and it has the property of what? Solid, liquid and gas. Fluid. It is a combination. Gases are also fluid. Why? Because it flows. If you leave gas, it flows. Normally, it will not flow in the ground, but it flows in the surrounding. Moment you open, you press a deo, or you maybe open a perfume bottle, it starts flowing in all directions. Yes. So fluid has the property of solid, a liquid, and the gas, and they're called the fourth phase of matter. Is it clear? Is it clear?
Yes, sir. Yes, sir.
So what are the various properties of fluid? What are the various properties of the fluid? Yeah. So what are the properties? First property, it is incompressible. It is incompressible. Its density is constant. What is density constant? What is density? Density is what? Mass per volume. Yes or no? Yes or no?
Yes, sir.
So an ideal fluid should be constant density. But you know very well that nothing in the world is ideal. There is no ideal concept. Nothing is ideal. Is there any ideal gas or ideal student? No. Everybody has some kind of disadvantage, some merit, some demerit in any of the thing. You take anything. So in ideal fluid will have a constant density, but that is not the case. Any liquid currently will have a constant mass, but the volume will vary. Because the volume varies, it will be having a varying density. So question will ask you, what are the properties of a ideal liquid? Understand, ideal liquid. Then what you will say? The ideal liquid has a constant density. Constant density. Second point, the flow is irrotational. What is irrotational? If something is flowing, it is rotational. See, the fluid is flowing like this, straight. But if it is rotating, the fluid will rotate and go. The molecules will rotate and go. See, when you hit a ball, when you hit a when the batsman hits the ball, firstly it starts rotating and then it slides. It will not rotate. If you have seen the batsman, if you have seen any replay, you will see the ball will rotate and then it will slide. If the ball is not rotating, it is sliding. So liquid, an ideal liquid, does not rotate. It slides, it flows and go. It slides and go. The molecules get slides. It is not rotating. Is it clear? Is it clear? So its flow.
Yes, sir. Yes, sir.
If the liquid rotates, then the flow is not smooth. It is very rough. So if ideal liquid does not rotate, it flows smoothly. It slides. Third point, the flow is steady. That means if you put a bucket of water, the bucket flows in this direction. At any point you take, the velocity is constant. The velocity does not change. But that is not the case. That is not the case. The velocity is different. That's why when you put the bucket, you will see some part of the area water will reach and some part water will not reach. You agree with me or not? You agree with me or not? Why? Because the velocity of the water molecules is not constant everywhere. It is varying. At this point, the velocity is maximum. Maybe at this point it is minimum. At this point it is not so much, it is not so less. So an ideal liquid will have a constant velocity. Is it clear? Is it clear?
Yes, sir.
Fourth point, constant velocity. Write down, guys. Constant velocity. Fourth point, it has no viscosity. It is not viscosity. the viscosity, like honey or jelly, it is so viscous. If you put honey, it will take time to fall. Yes or no? If you have seen small children, small babies, you remember the
Yes, sir.
saliva comes out. Have you seen the saliva? How it falls? It falls very slowly. Yes or no? If
Yes.
you have you seen that? Have you observed? So the saliva is
Yes,
also
sir.
very viscosity. An ideal liquid does not have that viscosity. That means it will immediately fall like water. See, water also has viscosity, but the viscosity should be zero. Then only it's an ideal liquid. Because no liquid is ideal, we see that there is a value of viscosity. Is it clear to all of you?
Yes, sir.
Is it
Clear.
clear? Hmm? Then there is something called solids can undergo subject to shear stress. We studied in 11th class. What is stress? If I put stress, if I take a carton box and I give a force in this direction, the carton box will become like this. How? Yes or no? Rishabh, we studied this chapter.
Yes, sir. I know.
It will get, it will deformed by what an angle? By theta angle. If you give more force, it will be deformed further. If you give less force, it will be so. This is called shear stress. Why? Because it is changing the angle. However, if you give a perpendicular force or perpendicular stress, it will become completely what? Completely like a plate. Yes or no? And what type of force it is called?
Yes, sir.
Longitudinal. What force? Longitudinal stress. Is it clear?
Yes,
Is it
sir.
clear?
Clear.
But you can you can give this stress to a solid, but you cannot give to a liquid. Why? Because liquid does not have any force only. It does not have any shape. Okay. So this stress is only applicable for, understood guys? Understood guys?
Yes, sir.
Hmm? So what are the properties of fluid? Not ideal fluids. They do not oppose deformation. Means if they don't oppose deformation, means if I am taking, if the water is there in the tumbler, if I put it in a jug, have you seen, if you put it in a jug, they will still take the shape of a tumbler? No, right? Immediately when we put, it will take the shape of a jug. Yes or no? That means they are not opposing deformation. They allow deformation. If something which does not allow deformation, it is not a solid, it is not a liquid. That means all liquids allow deformation. Is it clear? Is it clear? They do
Yes,
not
sir. Clear.
oppose deformation. I can only hear Rishabh saying yes. What about other three? Are you sleeping, guys?
Sir, I'm also telling you.
Hmm?
Both boys are telling you,
Participate.
sir. I'm also
Participate.
telling you.
Second, they have the ability to flow. They have the ability to flow. If you take ice cube, you put it there, does it flow? No. Immediately when you put water, it starts flowing. Yes or no? So all the liquids has the ability to flow. Is it clear?
Yes.
They have the
Yes.
ability to take the shape of the container. They have the ability to take shape of container. Whatever be the container, if it's a jug, a tumbler, or a saucer, or a ball, whichever container you put it, it is immediately take that shape. Understood? Is it clear? Hmm? Basics
Yes,
are
sir.
clear or not, guys? Please tell me. We have
Yes,
completed the
sir.
first
Clear.
page. All of you, Swaru, clear?
Yes, sir.
So coming to the next topic, fluids at rest. So the branch of physics which deals with the properties of fluids are called hydrostatics. And remember, hydrostatics, where do you see this? Have you just give an example? Hydrostatics, where it is used? Just think.
Sir, dam.
Dam.
Sir, is it something related to water?
Yes, hydro means water, no? Fluids at rest. So this is used dam.
Sir, energy generated by water,
No, but that is
electricity.
dynamics. No? That is water. That is dynamics. Yeah, we can say to some extent yes, because you are obstructing the water, and you are, after it becomes so much, you open the gates and it starts flowing. So that is there. But hydrostatics is more useful in brakes, hydraulic brakes. What is hydraulic brakes? Hmm? Have you seen a station where they will have, how will they lift the car and they will do servicing? They will have some kind of thing. Car will come and will sit there. Okay,
Yes, sir.
and
I
they
saw,
have
sir.
some kind of button here, so they will keep on pressing. So it is like this. I'll tell you how it is. It is like, yeah, we'll study about pressure. So here the area is more, here the area is less. So the force applied, because the force is constant and area is different, the pressure is different, and because of this varying pressure, the car gets lifted up. So we'll study about that. So the hydraulic brakes are one of the fantastic example of hydrostatics. Okay, hydraulic brakes, disc brakes, they have a oil. Remember, hydraulic brakes are very costlier. They are used in cars. Normally in the cycle you have seen, they are what, brush brakes. That means, and the brush is not so faster. Disc brakes are better. Why better? Because they have a oil. Do you know the disc brakes has the oil? You know?
Yes, sir.
Sir, in
Yeah,
bike.
yeah. In bikes,
Sir,
disc
they
brakes.
are also in bike.
Yes, car also has hydraulic brakes. Okay, they are not having these brush brakes are, they get worn out after some time, you have to change. And secondly, it is not so effective. If you immediately want to stop, you cannot stop using brush brakes. And if you use immediately, then what will happen, these brakes will break. So it is cheaper but not effective. Okay, we'll study about that. So hydrostatics is one of the fantastic physics branch which talks about how we are using the fluids at rest for the various applications. Okay, so before that, we have to understand what is pressure. What is pressure? Pressure is nothing but force applied on a unique area. That means, simple. I will I will take I will apply. There is Rishab's what do you call that? Cheeks. Okay. I will go and tap Rishabh. Okay. I will tap Rishabh with my palm. Rishabh will not feel the pain. Okay. I will apply the same force using a needle. Now tell me where Rishabh will feel the pain. The first one or second one?
Second one, sir.
Why? Why Rishabh? Why will you feel the pain in the second one?
Due to
Sir, it will poke inside me.
Why? Why? I understand it will poke, but why? Why does it
Sir,
poke?
area is lesser. No?
Exactly. So there comes a topic, pressure. The force applied is same, but the area is different. And you very well know that in mathematics, numerator by denominator, you can increase the fraction either by increasing the numerator or decreasing the denominator. So here the numerator is same in both the places, but the denominator is decreasing. Here I have decreasing numerator because the area is less. So the needle, this much is the area, but my palm area is more. Because the pressure is more, the needle will be more effective. Understood? Is it clear? That's
sir,
why,
I'm audible to you.
yeah, you are audible.
Okay.
Any question you have?
No, sir, I was only testing a mic.
Okay. So that's why the needle and the hand, even if I slap Rishabh or if I put the same force, it will pinch more. Question might come. Why? Because of this. Understood? And what is the SI unit of pressure? When you say force per unit area, So pressure equal to force by area. What is force? Newton. Area, what? So it is Newton. Is it clear? Is it clear? Guys,
Yes,
it is
sir.
clear. Pressure unit is a SI unit.
Yes, sir. Clear.
So I have other, so this is Newton per meter square SI unit. I have other units like bar or torr. So what is bar? What is torr? 1 bar is equal to 10 to the power Newton per meter square. So it's a bigger quantity. It's a bigger quantity. Okay. It's a bigger quantity. And normally we use Pascal also. 1 Pascal. What is 1 Pascal? 1 Pascal is 100 Pascal. They call HPA. HPA, it's called hetropascal. Hectapascal. Hectapascal. 1 hectapascal is 100 Pascal. Okay. So pascals, torr, bar, Newton meter square are various. But normally what we use is Newton per meter square. Is it clear? Newton per meter square. Is it clear, guys?
Yes, sir.
All of you clear?
Yes, sir. Clear.
So what is the next topic? We will study about pressure due to a liquid column. Pressure due to a liquid column. So let us take a container. Guys, can you rejoin? Let us continue after the rejoin. Just rejoin now.
Yes, sir.